Hi folks, it's me again, Tack. This time for my experiments, I'm still going to be using the acrylic material and I'll be looking at the surface roughness coefficients with using sandpaper and deodorant applied to the acrylic material. The main idea for this experiment is to use the Wenzel model to obtain the surface roughness coefficients. I'll obtain the apparent contact angle and use Wenzel's equation to obtain the surface roughness coefficients, and I'll also obtain the surface area of the droplets on each acrylic piece and calculate the surface roughness coefficient. So basically, I'll be doing two approaches to obtain the surface roughness coefficients and see which method is a reasonable approach. As I have mentioned that the Wenzel model will be used in this experiment, this is the governing equation that will be used to obtain the surface roughness coefficient. Theta app is the angle in which will be observed throughout this experiment. This is the apparent contact angle. I also broke up the two equations of which equals out the surface roughness coefficients, in which we have cosine theta app all over cosine theta Young, which is basically the cosine of the apparent angle all over the cosine of the Young contact angle. I also do have one more equation that corresponds to the surface roughness coefficient, in which it equals to the actual surface area all over the projected surface area. The actual surface area corresponds to the apparent contact angle, and the projected surface area corresponds to the Young's contact angle. So the main idea for this overall experiment is that I'll be looking at the apparent contact angle first for my first experiment to obtain the surface roughness coefficient. The Young's contact angle will just follow through of saying that this corresponds to a smooth surface, which I'll talk about towards my results. Materials used for this experiment are deodorant, isopropyl alcohol, lamps, which I have a desk light and a camping lantern, an acrylic piece, a cup of water, food dye, disposable pipettes, 220 grit sandpaper, 3000 grit sandpaper, and a 24-inch aluminum T-square ruler. As I have mentioned that I'll be doing two approaches, these are going to be my experimental setup. So I will have a side view setup, which consists of my iPhone as the camera, the pipette dispensing the liquid colored water onto the acrylic piece. A background would be very helpful to ensure that we get some good quality pictures of the droplets. A steady surface would also help as well. Also, lighting is pretty vital to ensure we get a really good picture of the droplets so we can analyze it with our PC. The second setup is basically a top view of the overall experiment, in which I'll be still using my iPhone to capture the surface area of the droplets, and having lighting is pretty important to ensure we get some good quality pictures again. And I also have my ruler to show the dimensions of how big my picture is going to be, so I can have that as a reference guide so I can plot out the surface area and obtain the area of the droplets easily. For this overall experiment, I have three procedures to follow. First, I'll talk about the smooth surface preparation. This is critical because we need to ensure we have the smoothest acrylic that we can have. And let me just go over the procedures. First up, we would have to sand the acrylic piece with a 220 grit paper. And I did this for about 20 seconds, both for counterclockwise and clockwise, to ensure we have an evenly distributed sanded acrylic piece. After doing step 1, I applied the isopropyl alcohol to the acrylic piece and wiped it off with a paper towel to ensure that we have all of the unnecessary material off of the sanded piece. Then I repeat the process again, kind of like step 1, but instead of using the 220 grit, I used the 3000 grit sandpaper. And again, I did this for about 20 seconds, both counterclockwise and clockwise. After sanding down with the 3000 grit sandpaper, I did the same idea for step 2, which I used the isopropyl alcohol to the acrylic piece to wipe off any residue that was left behind during the sanding process. Once I already finished the sanding, I was able to start the experiment a little bit with 2 drops of the liquid water onto the acrylic piece, and I was able to use the iPhone to capture my photos. Then after getting the photo, I was able to put it to my PC and extract the contact angle through WebPlot Digitizer. On to the second procedure. So this time I have a different acrylic piece, same exact material, but I also have 4 sections I broke it up into. And as we already finished using the ideal surface or the smooth surface of the acrylic piece, I distributed 4 areas in which I have area 1 as just the acrylic piece by itself. This is the untreated surface, so we didn't sand nothing or applied any type of coating onto the acrylic material. Area 2 is the deodorants applied to the acrylic piece. Area 3 is the 220 grit sandpaper applied to area 3, and we just did the same technique for 20 seconds, both counter and clockwise motion. And then area 4 is the 3000 grit sandpaper, also with the same technique, 20 seconds, both counter and regular clockwise motion. Once the acrylic piece is ready to go, I was able to dispense my 2 drops of liquid water onto those surfaces. And again, I used my iPhone to capture the photos of the droplets from the side view again. And once I got the pictures, I was able to upload it to my PC and analyze the contact angles with WebPlot Digitizer. After getting the side views of the droplets, I had to orientate my iPhone not from the side, but from the top view, so I was able to get the surface area profile. And as you can see, I also have my aluminum ruler to have as a reference guide to see how big the droplets are, and I can use this to plot this through the WebPlot Digitizer. And this is to help ensure that I have the right surface area value of the liquid droplet onto the surface. Onto the results. Here are the pictures I have obtained to get the apparent contact angles of the liquid droplet on the different acrylic surfaces. As you can see, I have the untreated acrylic surface, the deodorant applied to the acrylic, I have the 220 grits, the 3000 grits, and I also have the ideal acrylic surface in which I smoothed out with the 3000 grit and the 220 grit at the same time from going back to the preparation procedure. And I also used these equations to obtain the apparent contact angle, or I should say, the averaged apparent contact angle. From using the WebPlot Digitizer, it gave me the theta 0 and the theta 1 values, and what we're trying to find is just the apparent contact angle for both sides, and I use equations 1 and equations 2 to ensure I do have the right apparent contact angles for either the left hand side and the right hand side. Then using those 2 values, I averaged it out to get the averaged apparent contact angle for that droplet itself. I also have the results of extracting the surface area profile of the liquid droplets onto the acrylic material. So basically what I did, I had to reference a specific length on the photo, and I referenced the 1-inch mark from 11 to 12 and 18 to 19 inches, and this was for basically the 4 drops as you can see on the left hand side of the picture, and then the right hand side is basically the ideal smooth surface to extract the area profile of the droplets. Then once I was able to reference my specific length, I was able to plot out some of the dots around the droplet itself, which actually allowed me to get the surface area along with the perimeter. I didn't really need the perimeter value at all since we only wanted the area value itself. So once I was able to get the surface area value, I did notice that the data bar that showed up for the value of my area and my perimeter was interfering with each of the droplets. So once I was able to get my value for the corresponding droplet, I recorded it to Excel and I had to clear up that data bar so I was able to extract the other droplets more clearly so I don't mess up during my extraction. So that was the technique I did to get the surface area profile of my droplets. I also have some results. Basically, it's comparing the 2 approaches in which I got the contact angles from the acrylic surfaces with the droplets, and I also got the surface area of the droplets on the acrylic material. And as you can see, the surface roughness coefficients are just slightly different, but I'll show the percent error towards the end. And you can already notice that there's a yellow section that's highlighted, and what that means is basically my ideal smooth surface that I'm referencing from. As I did test out how smooth each material was with the coating or the sanded section, I can literally say that the 3000 grit and the 220 grit to the acrylic piece was actually really smooth. So that was my reference point to use. And I did use the equations on the right hand side, as you can see, to initiate to get my surface roughness coefficients along with my contact angle values and my area that I kind of converted. But you didn't really need to also convert it since it's basically the ratio of 2 of the surfaces from looking at equation 5 and equation 6. But I was pretty curious to kind of see how the surface area is in the units of meters squared. I also have the results again, but this time I have 2 graphs. So these are just showing the 2 techniques that I did for this overall experiment. And I plotted this with my surface roughness coefficient as my x, and then my apparent contact angle as my y for the first graph shown on the top. And as you can see, my data does line up pretty nicely just looking at my r squared value. And from going from left to right, I did have the 220 grit towards the lower surface roughness coefficients, and then going to the farthest right onto the top graph, I have my deodorants and acrylic material having a higher surface roughness coefficients. I also have another graph on the bottom, and this is basically the surface roughness coefficient versus the surface area of the droplet onto the acrylic material. And as you can see, my data does line up pretty nicely too. And from going to the farthest left side of the bottom graph, I have my ideal surface area, which is my 3000 grit and 220 grit with my acrylic material right at 1. And going to the farthest right onto the bottom graph still, I did have my 220 grit and acrylic material to be at a much higher surface roughness coefficients. This plot makes a little bit more sense than my other graph, since I did notice that the 220 grit with the acrylic material was more rougher compared to the other materials that I did have, like the deodorants and the 3000 grit acrylic. Then acrylic material itself is just almost close to 1, but it wasn't perfectly smoothened out since I was referencing the 3000 grits and the 220 grits. Now finally, here are the final results that I have for comparing the two approaches. And as you can see, there are two tables. The first table, which is on the top, I do have my surface roughness coefficients, in which I got the apparent contact angle and the surface area, and I decided to use the experimental value as the apparent contact angle approach, and then I used my theoretical value as the surface area observed experiment to get my percent error values. And shown on the bottom table, I do have the same idea, but instead of my experimental value to be the apparent contact angle approach, I decided to use the experimental value as the surface area observed, and I had my theoretical value as the apparent contact angle approach. And looking at the data and my percent error, I did see that the 220 grits and acrylic material did have a larger percent error in which I did conduct the experiment, so there could have been some flaws that I haven't taken account of, or the Wenzel model wasn't really applicable towards this approach. And I also looked at the deodorants and acrylic material, and it did still have a high percent error just from looking at the data, but it's not as high as the 220 grits. So it's safe to say that just looking at the sanded acrylic with the 3000 grits and then my super smooth acrylic piece wasn't too bad because we're just referencing that as my ideal surface. And looking at the acrylic material, it's still in the same range for the percent error for going both ways. Looking back at this whole experiment, just to conclude everything up, the experiment did run smoothly. It did have some flaws for just getting some of the data, and I kind of completely think that this was pretty tough to kind of go by, probably because I was overthinking many things, and acrylic wasn't really the material that I was really too passionate about, but it was pretty interesting to see the trend of what we kind of got for the data. And just from looking at what I kind of got for the acrylic material, it looks like that the acrylic material that I have is hydrophilic. And then interesting thing is that when you sand down with a lower grits sandpaper, I guess the material itself, the acrylic material, becomes more hydrophobic, as you can see with the 220 grits that have like some different values for my apparent contact angle. And one thing that I could have also looked into was to see what type of material that this acrylic piece was, because sometimes it's not really a perfect acrylic material. Maybe there's like some other materials composed with the acrylic itself just for manufacturing purposes that I'm probably not aware of completely. Also, to make this experiment a little bit more better, I could have looked into getting the angles much more better. Also, using maybe a different camera would help a lot rather than using my iPhone as the main camera. I also could have looked into analyzing the area more closely because maybe there could have been some errors. In other words, I should have analyzed a known surface area, maybe like a circle that I know for the dimensions, and try to compare it from the web plot digitizer to see where the discrepancies of my area value comes out to be, so I know the uncertainty value for when I get my surface area value. And then another thing was that maybe the droplets that I have placed onto the acrylic material was inconsistent, since I only used a disposable pipettes. And it's not like those fancy schmancy pipettes that we're normally used to see in the laboratory space. Thanks for watching the video, guys. Good luck with the rest of the semester.